Billionaires use it. Scientists use it. Presidents use it. And it's very likely that you're using it right now. Today, we're going to see what's inside a toilet and the path the flush water takes. But Iber, I didn't click on this video to see poop. No, I'm not talking about inside the bowl. I'm talking about inside, really inside the toilet itself. It's way more ingenious than you think. LD. When you press the flush valve, everything happens really fast. The water level rises. It starts to swirl, and whatever's in the toilet disappears down the hole. But there's a lot of engineering behind all of this. And since I'm going to explore the toilet, it's worth mentioning that here at Manual, they're all very clean and disinfected in just a bit. You'll find out how we're going to cut this toilet. But for now, what I need to do is mark a line exactly in the middle of it, which is where we want a saw to go through. I'll use a laser level and mark it with electrical tape on the porcelain. It's ready for the autopsy. By an incredible coincidence, I found out that a friend of mine from P-Date has a giant saw that he uses to cut stone. And if it cuts stone, it should cut ceramic too. We lined up the toilet well under the machine. And let's get the show started. First, run water to remove dust and cool the cut. And with the cart, I push the piece under the saw, which has industrial diamond tips that wear down the ceramic. The motor is very strong, so I barely have to use any force. I pushed it slowly because I didn't want to chip the edges of the toilet, and that's it. But the saw is enough to cut everything. Now I'll have to combine the cut with another one. I need to go over it again, but on the other side, making sure the cut matches the first exactly. Halahaha. Woohoo, very good. But my friend got another toilet, which I thought was sturdier. So let's cut this one too, so just to be safe. Because the machine is fun. Actually, in P-Date this morning, it was probably around 10 degrees Celsius and windy, but working with a machine like this is really great. This one is perfect. And you can't see the line between the saw cuts. We need to choose which half to use. Which one will be able to build the mechanism better to understand the engineering of the toilet. The white ones turned out well, but I think the gray toilet has an extra mechanism. It's right here. Look. So let's work on this one. Lucas is going to do a basic cleaning, because after this, we won't have access to these internal parts of the toilet anymore. And we need to dry it properly too, to remove all the water that the ceramic absorbed when we cut it. A few days ago, we did a test here by gluing ceramic to acrylic using silicone to see if it would work. Let's see. I had to use a lot of force, and it doesn't come off easily. The idea is to take this acrylic and stick it on top of the toilet so we can see what's happening inside. Hey, look, let's line it up. Line it up at the edge there. Don't press it, just let it go. Now we're talking. Look at this beautiful gadget. To help us understand the toilet, the first thing you'll notice here is that it's much more complex inside than we were imagining. There are a lot of cavities, holes, and passages. Let's start pouring water here to understand the function of all this. I'm gonna add a little bit of dye, so we can see better what's happening, okay? I hope there aren't any leaks. I'll add the initial amount of water now. This is the situation you find when you go to the bathroom. There's just a little bit of water here in the toilet bowl. If you look from above, you'll have the same view I'm having here. You only see a kind of little pond, but Since we're using our Super Toilet Bowl X-ray gadget, we can also see that there's water here, and on this side too. Something amazing is already happening here, which is this part of the toilet is connected to the sewer. So, everything past this point is extremely smelly. There are gases here that you definitely don't want coming into your house, not just because they smell bad, but because they can be flammable. The sewage that comes from the bathroom can produce a little bit of methane gas. And if that comes back into your house, it can even be dangerous. But that won't happen in your house because the toilet doesn't let it. Check out how cool that is. The gas will get here, and it finds a water barrier. This part of the ceramic doesn't let the gas pass inside, so that's already one of the biggest problems. Secrets. The toilet already has kind of an automatic valve to never let the sewer smell come back. We call this system a trap. You also have it in your sink, in the wash basin, and in the drain. It's probably going to have a different shape. Under the sink, you'll see a kind of S shape there, or maybe a little metal pipe where everything is happening inside. It has a different geometry from this one here, but that's the idea that the water itself prevents the gas from coming back. But hold on, it's not over yet. We need to see the toilet working because there are other mechanisms here, and for that, we'll have to simulate what happens next. You get to the bathroom, look at the water. Everything looks fine, and you're going to deposit some liquids and solids into the toilet bowl. We filled a balloon with water here to simulate what people usually deposit in the toilet. So let's do it. That needs to go away, and you're going to flush. There are two different systems there for you to put water into the toilet bowl. One is a valve that's on the wall. You press the button and the water comes. Normally, the water will enter here from the back of the toilet and will be distributed. And the second system, which I think is more commonly used nowadays, is the toilet tank. It's a reservoir, a kind of water tank that sits behind you. With a button on top, when you press it, it releases the water. This toilet is the type that uses a toilet tank. But we're not going to put the tank right here, because since it was cut, it won't fit properly. What we did here was rig up a makeshift toilet tank. Here there's a kind of stopper that we can release. Let's fill it with water. Lucas will help me. Yeah, this is the first time. Let's hope everything goes well. 3. And... so everything went wrong for me, right? Something you definitely don't want in your house. If you look at the footage, you'll probably see that a lot of water leaked here. That doesn't happen in real life because in the connection between the tank and the toilet, there's a rubber seal there. There's a gasket that prevents that water from leaking out. Because if the water leaks everywhere, you'll have to clean the bathroom every time. And there's not enough water to flush. The flush didn't work properly because there was too little water. What do we do here? I'm thinking that maybe this water outlet is also too small, you know? That the water should go down all at once here. If we could use the 3D printer to make an object that fits here, if it had a flap on top, we could glue the flap wherever needed. Then we make a stopper here inside, which could be with hot glue or something like that, and release it.
I make it square and cut it into 4. Then it will look kind of like a half moon.
Let's do this. Small. You can enlarge it, everything a millimeter bigger. It has to lock here. Ideally, you should add 2 millimeters on each side. Let's test it with 2 millimeters on each side. We managed to create an EVA stopper here that fits perfectly. That's what's cool about the laser. We keep prototyping until we eventually find something that works. Now we need to make a hole here and glue this thing onto a reservoir that has a flat top. Now, it looks a lot like a flush tank. We have new solids here to put in. And let's try to flush it. 1, 2, 3, and... we have a working toilet. Let's now analyze all this movement that happened here. When I flushed, it travels here inside the rim of the toilet. And you know that there are some little holes down here. So the water already starts to go down through the little holes. And this is important, so it can wash the whole toilet. It will go over the entire inner surface of the toilet. But in this case, with this one, that's not what's going to release most of the water. The rim is connected to a hole that exists down here. Not all toilets have this hole, okay? I think it's a pretty cool mechanism because it pushes any kind of solid that's lower down. It creates a really strong pressure so that everything goes away. Even solids in a real situation are less rigid. They break apart, they break down in there, and it's easier for the water to carry them away. The next step will be to fill this whole part with water. When that happens, the water gets heavy, and that's going to make it pull everything that's inside the toilet. Why am I saying pull in quotes? Because a partial vacuum will be created here in a place where there's low pressure, and the one that really does the job is the atmospheric pressure from the outside. It works just like a vacuum cleaner. Even in a vacuum cleaner, atmospheric pressure pushes everything into the wall. You can notice that it's only at this moment, when this partial vacuum is formed, that the solid parts really go away. There's one last thing that I think is cool, which is if the water stopped flowing inside the toilet right when the solids went away, the water level would end up really low. That's bad, since we want it higher to create a barrier that prevents air from passing through. So when the flush is almost finished, there's a little bit of water left here, which goes down slowly and fills up this whole space. You can see the water stopped at its maximum volume here, which is almost a guarantee. It's unlikely the water will dry up to this point and cause the smell to return. This little reservoir here, we couldn't figure out what it's for. I suspect it's just a structure to reinforce this part of the toilet, because the tank goes on top here. That's quite a bit of weight, and it ends up filling with water because you can't make a completely closed structure in a piece that's going to be fired. There has to be a hole, and that hole ends up letting a bit of water in, but that water will stay here forever. It's probably just a structural function. If you know otherwise, leave a comment. Even with all this amazing engineering working, one important thing is that the toilet always stays clean in daily life. When we really use it, there's dirt, stains, and microorganisms that can start to build up in various little spots here on the walls of the toilet bowl, intestinal bacteria germs. If you don't clean it, those yellowish stains start to form inside. And since the environment is humid, it kind of becomes a breeding ground for mold and fungus. And then there are people who, thinking they're cleaning, mix several cleaning products to make it really strong, but the effect can be the opposite. First, this chemical reaction between cleaning products can generate toxic gases that are harmful to your health. And second, this reaction can also reduce the effectiveness of the products themselves. A very common mixture is bleach, which contains chlorine, with various products soap, baking soda, lemon, ammonia, alcohol, and disinfectants in general. All these homemade mixtures are dangerous. Maybe you've seen something like this before. The person starts coughing and feels irritation in the nose, eyes, and throat. They may even feel dizzy or even have a more serious health problem. We've even made a video here showing an accident involving chlorine mixed with other things in a pool. Maybe you got curious to know how it's possible to make an object like this out of ceramic. And yes, there's a really good channel called Manual do Mundo that already showed this process a few years ago. It's really interesting.